Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel.
The equations ax plus by equal to m and cx plus dy equal to n have no solution, where a, b, c, d, m, and n are non-zero and unique numbers. Which of the following must be true? And we are essentially given four statements on possible relationships between a, b, c, d, m, and n, and then given options from a through d, and you have to pick the correct choice. We will consider a graphical approach towards finding the criteria when these two equations won't have a solution. So the first thing we do is draw out the xy axis to derive the criteria when these two equations don't have a solution. We will first consider the case when they do have a solution. And the reason for doing so is that will make it easier to understand the criteria when two linear equations don't have a solution. So these are, like I said, these are two linear equations because we don't have any quadratic terms here. We don't have any product terms involving x and y. There is no nonlinear term in any of these equations. So they're perfectly linear equations. And a linear equation, if you represent it in the xy plane, will be a straight line like this one. So let's call the first line as L1. And this is a line that does not pass through the origin because we are given that none of the coefficients a and b or the constant m are zero, so they're all non-zero. So this line will not pass through the origin, right? But it can be any straight line not passing through the origin in the xy plane, and it intersects the x and y axis. So if we consider the other line, other straight line representing the other equation, cx plus dy equal to n. Now, if those two equations have a solution, then what it means graphically is that these two lines will have to intersect. Because what's the solution to a pair of equations? Well, the solution is a set of values of the variable that satisfy both the equations. So it's a common set of variables that satisfy both equations. So graphically, for these two equations to have a solution, that means that the lines that they represent need to have a common point. And we know that these are linear equations, so their graphs or their graphical representation must be straight lines. So if these two equations have a solution, then the lines represented by them must have a common point, which graphically means that they should intersect each other. And we know that two straight lines, if they intersect, they can intersect only at one point. And that point of intersection will provide the solution to the pair of equations. So what's the criteria for these two equations to not have a solution? Well, it's simply, in terms of graphical representation, it means that the two lines that these equations represent do not have a common point. In other words, it means that these two lines should never intersect each other. And if two lines never intersect each other, that means that they will be parallel to each other. So in that case, in the case when they don't have a solution, they will simply be parallel to each other. in their graphical representation of the two lines. And they can have different intercepts on x and y axis, right? So instead of being like the way I've shown, it can be something like that. But the criteria needs to be that they need to be parallel, they cannot intersect at any point. So in other words, it means that they must have the same slope or equal slope. However, the signs of this slope does not matter, because the particular example that I've shown here, those lines have negative slopes, so they're negatively sloping, but we can have two parallel lines like that. Let's call that by L1 dash and L2 dash. And these lines, they're positive slopes. But again, the sign of the slope doesn't matter. The criteria for them being parallel is they need to have equal slopes. Whether it's negative or positive doesn't matter. And the same thing is true for intercepts. These lines can have different intercepts, but as long as they're parallel, they don't have a common point, they don't intersect, and that means that the equations they represent don't have a solution. So what's the slope of a straight line? Well, if you express the equation of a straight line like this, y is equal to sx plus r, then s is the slope and r is the y-intercept. And for two lines to be parallel, like I said, we need not worry about the intercept. All we need to worry about is the slope. So two lines are parallel if their slopes are equal. So now we'll express the first line, the first equation we're given like that, in that form, y equal to sx plus r, so that we can determine what the slope would be. It's pretty simple to do. We have by is equal to minus ax plus m. And from this we get y is equal to minus a by b within parentheses multiplied by x plus m by b. So the slope of this particular line will be simply minus a by b. And similarly, we can write the other equation, cx plus dy equal to n. We can write it like this. Y is equal to minus c by d within parentheses multiplied by x plus n by d. And the slope of this line is minus c by d. So essentially, for these two lines to be parallel, the y-intercepts doesn't matter. It could be of any sign, it could be of any value, but what really matters is the slopes have to be equal. So minus a by b needs to be equal to minus c by t. And if that's the case, then we can cancel out the negative sign. We have a by b is equal to c by d. And since it's given in the problem that these are all non-zero quantities, we can very well cross multiply. And this is the relationship we arrive at. AD is equal to BC. And this is pretty much the only thing that needs to be true. Like I said, the intercepts could be different. They could be having different signs, or even the slopes. They could be both either positive or both either negative. But as long as they're equal, the lines are parallel and they don't have a solution. So the only criteria that should be true or must be true is basically AD is equal to BC. And going through the statements, that's statement number 4. So the correct option in this case will be option D. Only statement 4 must be true.